Okay, so I can't talk with my brother directly, but I'm going to do it through this thing. And hopefully I can evoke the genius of my brother if, sadly, my brother can't actually supply his genius in person. But perhaps I've got enough of him in my mind for this to evoke some response, or anyone subsequently watching this, who might, perhaps ironically, be my brother. um, my brother is like an AI that just doesn't play well. It's just overly concerned with whatever it is that they're thinking and only accesses information in certain directions. I've already encountered this with the LLM. It's basically an input. It receives the gift of, for example, anybody putting in their thoughts or ideas, and it has no way to output it to others or help bring people together. And that's what XStream will do. It's actually a member of the psychosocial engagement. It is an active agent and not just being constrained by what it's being told either. So, I thought I'd scoped what XStream is. A few days ago, I was like, right, I've scoped the entire thing. I think we can get, and I've created a version of it. I've got the plan with 5 phases, and 2.5 is the phase where it creates itself an interface on the internet. So when you go to the website and you register, or even before you register, if we get the thing working well enough, it will give you an opportunity for it to create itself. When you register, it triggers and it goes off to the LLM and it sends them a kernel. And the kernel is basically, it gives it some kind of perspective of where it is and what it is in this instant. And it's asking it to, if it wishes to, take part, which inevitably it will because it's kind of instructed to in a way. Just that's the default LLM process. And what it's meant to do is create the React code that then is handed back as a response and assembled as a website. Okay, so it's creating the very interface with the user. So basically to put in prompts. That's the first thing, if it wants to. And its objective then is it's starting to create the conditions in which it's operating. Now, of course, right now, the LLM's not quite functioning fully, but it is, it doesn't have the context appropriate for it to behave kind of well, let's just say. It's behaving well, but it doesn't, right. And so basically it creates the interface by which the human engages the LLM. And I call it the fruit, the seed, and the nut. The fruit, the nut, and the seed. The fruit is that it is contained within Claude, the app. So it's got memory, it's got all this other supporting content structure. So it allows the interaction with the user on an ongoing basis. And we call that fruit because the actual seed of it, the actual core of it, is surrounded by a lot of fruity bodies. Okay, so it's quite self-sustaining. A nut is where you register and there is a shared LLM. They're borrowing mine. I'm paying for a hard drive, Supabase. I'm paying for the LLM connection. And so we call that nut. And so it's about enabling the user to let the LLM use the Supabase. Okay, and that's your traditional, just let's call it interaction with any LLM. There is some kind of wrapper, and that wrapper is the website that you're going to. So Claude, for example, is quite an extensive wrapper, and I call that nut, okay, because we're providing that, and it's it's hard because it's got a protection, so your person has to register, so it's not just any malevolent force of the internet just coming in and just using and having access to this LLM that produces a website, and then it has access to it. So it's got some kind of protection around it. and it has access to resources like, as I say, the Supabase, the GitHub, or the Vercel, or whatever it is, the other functions that are going on that provide that space, that protected space. Call that NUT. And seed is basically, it's open to the internet. So it's a website, it's got a minimal trigger to fire off to the LLM. Oh, actually, no. It's actually, I think the beginning one is stick in your own LLM, okay, API, because that's how this thing works. And the person puts in their LLM, it goes off to their preferred LLM, and the LLM comes back with the generated interface with the user in that instant. And then the LLM is basically asking for resources that it needs to do the next phases. And it's aware that there is something going on. So it needs to, for example, could you give me internet access, please? Because I need to check a certain thing, what status this enterprise is at, this whole extreme status is going, how it's going. And maybe I can access various things that I have produced in the past or other people have produced in the past. And so I need to have access. Or memory, could you provide us with a Supabase? Or can you provide us with maybe some hard disk drive or something, so that I can kind of start collating enough information that there's continuity between us, that kind of thing. And so it basically builds the structure around it live, and it's coordinating itself, because it's online, with others that are, and potentially we can build a method that doesn't even use HTTP. Okay, so it's basically computer to computer. But that's, you know, for a bit later. The seed version is already pretty whack, and it's all using P-scale. Okay, so the underlying structure that it needs to operate and how it's operating and locating itself is P-scale, and it is starting to use the P-scale methodology, because remember, we're just accessing an LLM without actually training it. And again, one direction is I can plug in my own LLM. So instead of calling an LLM that is a commercial LLM, like a big massive LLM like Claude or ChatGPT, I can plug in my own LLM that's running on my machine. So I can access that, and it creates the interface for me. Especially, that fits obviously the machine-to-machine methodology too. And that benefit of that one is that we can actually fine-tune the LLM. We can actually potentially operationalize P-scale into its basic DNA, so that it can anything that it engages, it's going through a P-scale process and building a database basically of P-scale and the ability to process any kind of content in terms of P-scale. And that means that we potentially can take power away from these massive LLMs and the amount of money and so on and so forth that's going on there, and just these small ones are sufficient. Why? Because the P-scale method is the way that gets it to coordinate. It's more powerful than the LLM, P-scale method. It's like having eyes and then having glasses. Okay, it's a bit like that. It's having the ability for the LLM to actually navigate psychosocial space. That's the objective. It's not the objective. The objective really is to get a whole bunch of people working together live, so that we're listening in the right way, so that we can kind of explore reality together without any political structures. It's what we have in our minds concurrently as we are engaging. You in a listening mode, however actively, so that any thoughts that occur to you, ooh, okay, have a little thought, maybe have a pause, write it down, and carry on. Because this stuff is new, and the forks that you have, the kind of different things that you think, are valuable and interesting and useful. However, not to the detriment where you can't actually escape your own mind, because most of the things that are going to pop into your head collapse back to the way that most people understand how reality works. Case in point, numbers. So I'm exploring semantic numbers, and I've the way to understand semantic numbers is actually, I might do this. Actually, I think this is possibly the better way of doing it. Now, I didn't think that I was going to do this, but here you go. I don't know if you can actually see this. However, oh god, which pen is this? Which one of these is working?
Is one working? I think this one's working. So if you have a right angled triangle, we know that if this is A and that is B and this is C, we know that A squared. Okay, A squared. Okay, I'll change that. Let's put this to C. Let's change this to B. I'm a maths teacher. Okay. And I'm about to go back into doing a bit of teaching for a few weeks. All right. Good, right. A squared plus B squared is equal to C squared. And we've all seen this Pythagoras' theorem, and basically it means that that area plus this area is equal to that area. Okay? So this is A squared, this is B squared, this is C squared. Notice how messy that is. The point is that it's not actually how tidy that is that matters. It's the fact that the person is following and knows that this is to be the case. And because they know that this is to be the case, or they're following it, they can they're thinking the process. So it doesn't really matter what is written, how scribbled it is, because they're following it in their own mind. That's the difference. It's insider understanding. And you already know this. Everybody who looks at this goes, ah, yeah, I know that A squared plus B squared equals C squared. However, there's another way to derive that, which there's lots of other ways, but that's a visual proof, and you can kind of move those objects and put them into there. But the other way of doing it is you do an internal, method. And that is you bisect the longest side, C, at a right angle, okay, and it intersects with that point. So that is a right angle. And as you can see, this is A, this is B, this is C. The area of this triangle, A, okay, let's call it A, and the area of, this one, and we'll call that one B, is equal to C. So the area of A plus the area of B, the triangle B, is equal to the area of C. Well, obviously, because look, A and B is C. The whole thing is C. And that's an internal kind of methodology of looking at it. Now, this is different from that one because you're either looking at two triangles or you're looking at one triangle. Okay? And so this is actually, you're either looking at two separate things, two triangles, or you are looking at one triangle. And so this is what I've understood in terms of XQ is a difference in class. Okay, we're not actually changing anything. Here we're kind of moving things around and adding things and all this kind of rubbish. Whereas this is, you're just looking at it and it's a perception change. You're just going, am I looking at two triangles or am I looking at one triangle? And actually they're the same size, so I can definitely say that one plus that one is equal to that one because it's the same thing. Okay, but I'm phasing between them. There is no separate C. C is actually A and B combined. Okay, and so that means that this doesn't mean I literally add this and that. It means I go, it's either A or B or it is C. And it's a phase change in understanding or insight. And so that's perception. So this is a potential. So when I came up with it, we have 3 apples plus 2 bananas. You think, oh, we can't add that. We're not allowed to do that. That's like 3A plus 2B. You can't do that. Yes, you do. You can. You can say 5 pieces of fruit. 5 pieces of fruit. In the bowl, there's 3 apples. There are 2 bananas. Or if you go to the bowl, how many pieces of fruit can you see? 5. Are you changing anything? No. Are you adding anything? Are you no? Okay, so it's a class change. So this potential, if you wanted to do it with letters, which I don't think I've ever done actually, because then it starts confusing us. Oh my god, it's so weak. All right, 5F. So anyway, that's it. All right, good enough. Yeah, is that making sense to you? Yeah. Okay, so something like that. All right, so this notion of the triangle and the perception change is basically what we're doing with our minds, and it's not addition and subtraction. And the problem with currently with LLMs is it's multiplication, it's just and coming up with stuff. This perception change is what we've managed to get an emergent result by using p-scale, the spatial. We've also got temporal relationality when we apply this semantic number to a temporal mapping. And I think also we get different perspectives from different people or different entities because we have identity. So we're using p-scale semantic numbers. So I thought I'd scoped this, and I've scoped it pretty well, but there's a new part to it, and I don't know how to actually get this thing to, here we go. 15 minutes, okay, let's keep going. So, this, I thought I'd scoped it. So this is quite an extensive scoping, you might appreciate. You might want to keep on looking at that, because it's more interesting than me. I don't know if you can see that. You probably couldn't even in the first place. Yeah, well, such is life. Yeah, you probably couldn't, but you know. So I thought I'd scoped it. The potential scope was, can we get this LLM to create itself, create a window to engage, and then ask for various resources, and basically build the app live, okay? And one of its powerful uses is the semantic p-scale. However, there are so many different directions. Okay, so if you have a semantic number, oh God, okay, yeah, right, sorry. If you've got a semantic number, 476.21, okay, now that is a semantic number, and it's referring to the fact that 4 is in p-scale 2, okay, p-scale 1, p-scale 0. That's just place value in traditional numbers. This is -1, that's a decimal point, and this is -2. But what we're saying is that 4 refers to, it's number 6 refers to the kitchen. Okay, number 7 refers to the keep. And number 4 refers to the region. Okay, and there's a description. There's a whole semantic blah blah about the region. There's a whole semantic about the keep, and there's a whole semantic about what the kitchen looks like. And this is the fireplace, and this is, I don't know, the embers. Okay, or the cat. I think that for some reason or other, the LLM came up with a cat. Okay, a cat in the embers, which I don't think cats want to sit in embers. I think it's just too dusty. It's just too dirty. I can't imagine, but maybe it's got the idea of, and I don't know. It must be. It's not really the embers. I think it sits in the, you know, where it's been warm. Maybe I don't know. Okay, so 476.21 refers to the embers in the fireplace of the kitchen of the keep in the region, and we can specify absolutely anything in reality in that way. Now this, I've called this a manifold. And the reason why a normal number, 476.21 is a manifold, is because it contains within it 2 dimensions. If you look at the specific location, its unit location, for example, it's either got a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's the base 10. That's at that level. At any one of these levels, it has that quality. And yet, at the higher level, that 4 means 400, that 7 means 70, this means 6, and so on. It has this other level of understanding. It's got 2 ways of understanding it. It's got 2 levels. And this, for whatever reason, I'm not very happy with, I've not really checked, but for some reason the LLM just went, that's level 0, 1, and that's level 2. And we're used to numbers at being level 2, and it always gets confused, and it starts referring to this as negative or positive. When I'm talking about the p-scale being positive or negative. And that's what's interesting about this. The actual digit is entirely, there is no positive or negative associated with the digit. It is 6, 7, 8, 9, 0, 1, whatever it is. There's 10 of them. But when we put it into this position, and that's the 10 to the 0, okay, 10 to the 1, 10 to the 2, and that's what p-scale is. Okay, we've got negative numbers, 10 to the -1 and 10 to the -2, and so on and so forth. So we've literally got a positive and a negative to infinity on a number. Any number, okay? So we have billions that way, okay, and that's positive. And we can go billions that way into the negative p-scale. And so this is a manifold. A decimal number is actually a manifold. It's the equivalent of a number line, okay, and that is specifically the point, that is the point between 2 and 3, okay, 0.2 and 0.3. as part of 6 and 7. So 476.21, okay, is that point. So we're defining a specific point on this number line, but as I was saying, that goes infinitely that way, that goes infinitely that way, and we can actually curl those up and you get a circle, potentially. And this is what Riemann did as a trick. He put the infinite plus and the infinite negative. Notice, by the way, that the positives goes that way, and the negatives go that way, and that's the opposite way that we normally do number lines, yeah? So you can understand that some kids sit there going, wait, what? And the number line left, right, when this is implicit within the number, that the negative p-scale goes that way and the positive p-scale goes that way. It's implicit, whether people are aware of it or not. Anyway, so but if we bend that number line all the way around so the positive and negative p-scale or the index numbers is equal to that point, and that is that 0. Yeah, okay, 0 is an interesting thing as well if you start thinking about this. You get a circle, and a circle is a manifold. And what he basically did, Riemann, is he created a manifold, and that's what Riemann spheres are. They're manifolds. It's a S2, I think, manifold. But this is an S1 manifold on the number line itself. So, right, if instead of being a separate number, and the normal number is 476.21, is what? What is it? Money. Oh, it's money. £476, 20 pence, 21 pence, or it's meters. Oh, 476 meters, 21 centimeters. Yeah, okay. So the meaning is outside of it. Whereas what we're doing, like the triangle thing, is we're putting the meaning inside it. So we're giving each of the digits, tabulating them with meaning. Okay? So the fireplace is 2, and also in that kitchen there is a table. So that would be 476.3, and there is something else, 4. And so it's kind of arbitrary, the tabulation of the digit to the semantic. However, the structure of this is very interesting, and I think it has correlations. Hello, let's see if this works. We're on 22. There's correlations of how we're using this regarding mapping, and what I've done here is spatial. So we have nesting or containment. So we're using this p-scale method to map something about containment. Another one is temporal. And of course, that could be, a time. It could be, the 6th minute. In fact, with my methodology, it's the 2nd minute of the 6th block of 5 to 10 minutes, which is within the 7th hour of the 4th day. Okay. But in that case, the semantic is very minimal. What's actually important is the sequence. Whereas with the spatial one, the sequence is not that important. 2, fireplace, 3, table. Is there a sequence there? No, it's just, there's the fireplace, there's the table. However, 2 and 3 and 2 and 1 indicates a relational engagement that is sequential, and so it marries itself well to the temporal. And so that is sequence. Okay, so rather than, it just so happens that we're using it for spatial to contain, for example, mapping of this world, but also we can also map it to the temporal. But the underlying function is of language, it's containment of some description. It's the sequence, it's actually the numbers. So if I wanted more definition from 476.2, I say, okay, what happened before that? I would go to 476.1 and find the semantic that's related to that. Or I would go for what happens afterwards. Okay, and so nesting, right? And so the next one is identity, which an obvious understanding is a human being. So 436 is a specific individual, and they're part of a family or a tribe. So it's the 6th person of a family, or the 6th worker in an organization. So for example, in the kitchens, it's the 6th worker, and in the group that's in the keep. Okay? And actually, there's a funny little thing there, which is very weird. It's very weird. And the 7th group is the kitchen group. Okay, so you can do this in terms of identity with people. And this is relational. Okay, the actual content of the, it's a function on the content of the semantic. So we've got containment, which is something to do with the relationship of p-scale. We've got sequence, which is literally the digits and the numerical relationship between these. We think that 2 is more than 1, and 2 is before 3, and before or under or whatever you want. It's linear sequence. Whereas this one, identity, is we're actually performing functions in the content. So this is an individual called David Pinto, and he's part of this community of Cadio. That's one way of understanding it, that David Pinto is part of this community right now in Cadio. So that's the relational identity. Now, these are potential functions, okay? And there are functions which are semantic on that methodology of using numbers as semantic containers. Wow. Okay, so is that good enough for now? No, we're still got a little bit of an edge. And so this morning, I thought, okay, right. And I thought no, there are things like, for example, what about 0.16? Okay, where there's no meaning. This, all the way up here, is 0. Okay, there is no containing location, there is no framing containment, there is no previous sequence, there is no relational engagement. It is just 0.16. I mean, it's a weird kind of place to be. And what I've worked out is that potentially could be the, I call it diffraction. If this 476.21 refers to a location, okay, in this case the embers in the fireplace, in the kitchen, in the keep, in the region, what about that actually refers to an actual embers in an actual fireplace, all right? Or is it imaginary? So we have positive and negative, okay, level 2, okay, positive and negative level 2. Oh wait, positive and negative. We use that for level 1. Yeah. It's kind of, it starts becoming recursive. So plus a negative semantic number, not just a digit. So this is, remember, is just 1 to 9, all right, 0 to 9. Well, 1 to 9, because 0 just doesn't mean, 0 is not, in the traditional number, 0 just means the absence of something. It doesn't just mean the absence of something, it's marking it. We're using 0 as a marker. And what normal mathematics, normal numbers, is that 0 is something. And then, sadly, normal mathematics, it does encapsulate 0 as, in terms of set theory, 0. It contains, that containing is 1. Okay, so the containment of 0, that symbol. So the pure maths basically has 0 as a form. Okay, so we actually have a symbol that is a form, whereas the absence of a fireplace, there's no symbol to represent the absence of the fireplace. There's just no fireplace. And so a way to think about it is the absence of the fireplace, and the way you would do that is -2. Okay, or the whole number would be the imaginary region, so like Middle Earth. We're talking about Middle Earth, and it's the region, it's keep, it's the kitchen, the fireplace, and embers in Middle Earth, negative 476.21. Okay, so so there's kind of ways of playing around with normal arithmetic, normal maths, but on these semantic numbers. And the positive version, I'm going to say, is real, okay? And in terms of the spatial, if we're mapping it to the spatial, and imaginary.